Ding. It's ready. Y'all are getting recorded as we speak. All right, if y'all get your homework out from yesterday, please. We're going to try to go over a couple that you might have questions about. We don't have time, obviously, to cover the entire thing, but I'll try to do a couple of them with the time that we've got. So what you got? What questions do you have? You weren't here yesterday, were you? Did you get your note sheet and homework yet? You're welcome. You might have a question? Y'all feel good about it?
I did.
All right, what you got, Sierra?
Can you just please go over how to find the y-intercepts?
Absolutely. So which one would you like me to look at to show you?
8.
Number 8. All right, we'll look at number 8, and in doing that, we'll make sure you understand how to find those y-intercepts. Jay's got TDL. I don't know. No clue. All right, so number 8. First of all, I want you to look at the base of the exponent. The base of the exponent on that one. What does it look like your base of that exponent is? On number 8. What's the base? Excuse me, the base of your exponent.
4.
Nuh-uh. On number 8.
Oh, 2.
It's 2. Okay, so what does that tell me? It tells me it's going to be a what?
Smaller than 1.
No, 2 is greater than 1.
Oh, wait. Oh.
So since it's greater than 1, it tells me it's going to be a exponential growth. It's going to have exponential growth. It's going to increase, okay? So let's go graph it, but I already kind of know what it's going to look like. So let's see what we got here. We got 1/2, so alpha y equals number 1, 1/2. And then it says times 2 raised to the x. And then outside of this, okay, you got to scroll outside of this and put -6. Okay, now look, I just want to kind of, before I graph it, I want to talk you through this because I think it's important to notice the things before you graph it. That way you can kind of expect something. That 1/2 at front, remember that tells me it's going to vertically what? Compress it. I won't really be able to see that very well, okay? I don't know enough about exponential functions to really see the graph being smashed. But that's what it does, okay? The thing I can see, though, is what is that value outside subtracting 6? What's that telling me? It's shifting down 6. Now, yesterday we talked. What does the shifting down, what does the vertical shift do to my graph? It changes the asymptote. It changes the asymptote. So the point I'm making here is this. When I graph this thing, I should see this thing make a drastic change from what those graphs did yesterday. It should come way down. Let's see if it does that. Graph. Did it come way down? You see my bottom wall now, that asymptote, that wall it cannot pass, it came all the way down to -6, okay? All the way down to -6. So that's going to affect my graph. Now, let's go look at our table and come up with some good points, including the one that Sierra specifically asked about. Okay, now, right in the middle of this graph, Sierra, I've highlighted 0, -11/2. Why? Because my y-intercept is always found when x equals 0. So for all of these graphs, if I want to find my y-intercept really quickly, really easily, just go to where the x value is 0. So where's my y-intercept here? 0 what? 0, -11/2. -11 divided by 2 is -5.5. So I'm going to go down to 5.5, and I'm going to graph that point. And I got a couple of other good ones too. I've got 1, -5. I've got 2, -4. I've got 3, -2. I've got 4, 2. And I got the 5, 10, but I don't really need it. I got plenty of points. So here's the thing I'm going to consider when I graph this one. One, you got to go through your points, right, to the best of your ability. But what's the second thing that's extremely important for this, to graph it? My asymptote moved to where? -6. That means, guys, there's an invisible wall right here, and my graph approaches it, but it never crosses it. So I want to hug that line to the best of my ability. Okay? So try to imagine that invisible wall there when you're graphing your exponential function. And it gradually goes up, goes through the points I'd already labeled. Got a little off there. And there you have it. Again, it doesn't have to be perfect. Mine's not perfect, but it's good enough. It tells me two things. I never came down below my barrier wall, which is y equals -6. So my asymptote over here is y equals -6. Right? That's where it shifted down to 6. And then, of course, my y-intercept, we just said, was 0, -5.5. So always find your y-intercept where x is 0. That's where you find it, okay? Yes?
So the fraction you get, do you have to divide that to get the decimal?
That's what I did.
Is that what you want us to do?
It wouldn't have mattered. If you put 0, -11/2, 100% right. So it's your call. I changed it because when I go graph it, I can't graph -11/2 on a graph. I can graph -5.5. Does that make sense? Even though they're exactly the same value, I got to think about the decimal to graph it. So that's why I wrote it. It's no big deal though. Okay, so what's my domain? What do we say our domain always is for exponential functions? There's no limit, right? No limit. So -infinity to +infinity. Now, from those graphs that we did yesterday, the range changed, didn't it? Why did the range change? Yesterday, all of them were 0 to infinity. Why did this one change? Because my asymptote changed. That's why it had to change. So now, what could y equal? Everything from -6 and above. So my range changed from 0 to infinity to -6 to infinity. Okay? And that's why, because my asymptote changed. Now, as far as the end behavior, as x is going to the right, guys, what's y approaching? Positive infinity. Look, it's just going up, 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 up. But as x is going to the left, what's the furthest value y can approach? -6. And there you have it. Okay, that's how you can do your graphs for exponential functions. Okay? Any other questions? The homework last night was 1 through 5, 6, 8, 10. 1 through 5, 6, 8, 10. Did you already know that? How? Oh, okay. I thought maybe you just read my mind. All right. No more questions? Okay, so remember, this is due when? Today. So if you're finished with it, bring it up to the folder. If you're not quite finished with it, you need to upload it sometime today. We're going to do something that I think you guys are going to find to be easy. You know why I think that? Because all the other classes have. And y'all generally are one of my upper level achieving classes. So my assumption is y'all will get it too. Even though y'all do smart off sometimes. Aiden, you do. That's fun. Now who's on record? Looking bad on video.
30 subscribers.
Aw.
I'm sorry.
Famous. Wow, what a dagger right to the gut.
That was
Jeez.
uncalled for, I'm sorry.
No, I'm just joking.
Don't
It's fine. I didn't start the channel to try to get famous or anything. I was only doing it to try to help my students.
Yeah.
That's what
It is the truth. Okay, now, so what we're doing today is there's two really good ways to solve exponential equations. Okay, two really good ways. The way that we're going to learn today, and another way where we have to use these things called logarithms. Right? They're not that bad. Okay, I promise. They're not that bad. Logarithms is just another way of writing an exponent. Now, here's the reason we can't always use one method or the other. We're using these methods, what we're doing today, when we can make the bases the same. But sometimes you have exponential equations that no matter what you do, you cannot make the bases the same. And therefore, you have to have that other method, and that's where the logarithms come into play. Okay? So today, we're actually going to be dealing with all equations where you can actually get your bases the same. All right? So here's my process. Step one, you got to look at both sides, and you got to make sure you can simplify them as far as you can simplify them. Okay? So simplify each side. Step two, you got to make your bases the same. Step three, you drop those bases off and you take the exponents that are remaining and you set them equal and you solve. That's our process today, okay? Now we're going to start with the easiest one you could possibly imagine. Let me explain why it's the easiest one you could possibly imagine. For this problem, on the left side, is there anything I can simplify? Nope. On the right side, is there anything I can simplify? No. So there's no step one. The second reason why it's easy is what do you notice about the bases? They're already the same. So no step two either. You don't have to create them to be the same. They already are the same. So for this problem, we can go straight to step three. And that is, when the bases of exponents are the same, you can drop those bases off, cancel them out, and you can take the remaining exponents and you can set them equal and solve. What's the exponent remaining on the left side? Not all at once. X plus 1. What's the remaining exponent on the right side? So we're literally going to take x plus 1 equals 9 and solve. How? How do we solve that?
Subtract 1.
You subtract 1. What's 9 minus 1? So my solution to this exponential equation is 8. That's it. Okay? Now obviously this is the easiest of all the problems. Okay? It will get gradually, there will become more steps gradually. I don't want to say it's just going to be harder. It's just going to cause me to think a little bit more. Okay? So, go down here with me to number 3. And first of all, let me just remind you guys, tell you, I don't know, it's not reminding. Tonight's homework is the right side. Okay? I'm not giving you a separate worksheet. We're going to do the odds, and you're going to do the evens. Okay? Everywhere. We're going to go throughout all the odds right now in class. It won't even take us that long. Okay, look at this problem. This one has one step more. Look at the left side. Is there some things to simplify?
Yes.
Yeah, because look, we have two bases. 3 to the k times 3 to the k plus 2. Now let me remind you guys, how can we get those bases together? Well, remember x squared times x to the third? When those bases are the same and we're multiplying, how do we get them together?
X to the fifth.
By adding the exponents. 2 plus 3 is x to the fifth. And that's how Aiden came up with that, right? So how do I get those the same? How can I get 3 and 3 together as 1, 3?
3k squared plus 2.
No. What did we do with these exponents?
Yeah.
We added them, right? Well, what is k plus 2? So that becomes 2k plus 2. We added them. And k plus 2, we're allowed to combine the k's. K plus k is 2k. Does that make sense?
Would you also like combine that to like 3?
We'll get to that one, okay? Yes?
I can't see that really well. I forgot my glasses.
Then you might want to, like,
We can't see that.
find,
Not
Stand
well
right here.
enough.
You should
I
just.
can see that
I mean, if you can't see that, I can't.
She can sit like on that chair and bring her.
I mean, you can, whatever you need to do to try to get a little closer is fine with me. I mean, I don't know, Michael, would you mind just backing up one seat? Can you see okay from that next seat behind? Will that work? Thank you, Michael. All right, is that better? Okay. Now, on the right side, there's nothing to combine or simplify, so we leave that alone as 3 to the 5k minus 1. So look, guys, step 1 we just completed. We simplified what we could simplify. Step 2, create the bases to be the same. Well, do I have to create it? They're already the same. So step 3, we do what? We drop off the bases. And what's left over? 2k plus 2 equals 5k minus 1. That's it. That's all you do here. So, remember, there's variables on both sides. I like to move the smaller one. Which one's smaller, 2k or 5k? So I like to move the smaller one. How do I move 2k? Subtract 2k. So 2 will equal, what's 5k minus 2k? So 2 equals 3k minus 1. Now what? Add the 1. What's 2 plus 1? So 3 equals 3k. And then finally we divide by 3. So k equals 1. Does that make sense? Alright, let's step up our difficulty level just a touch. Not a big time, just a touch. And this is kind of where the rubber meets the road. If you understand what we do on this problem, it's going to make the rest of them from this point forward a lot easier. Okay, look at the left side. Can I simplify anything? No. Look at the right side. Can I simplify anything? No. Okay, there's nothing I can really simplify. But, secondly, we got to make the bases the same. Are these bases the same? No, on the left side it's 6. On the right side it's a 36. So I can't go to step 3 where I can just drop off the bases and solve. I got to create the bases to be the same. Anybody got an idea of how to do that? Kind of, but no.
Can you just divide?
You're so close. You can't divide because remember, if you divide, you're dividing everything.
Can you just turn the 36 into a 6 with a square on?
That's it. Okay? So you weren't far, Deanna. But the point is this. I've got to create 36 to look like 6. Because what is 6 times 6? 36. So I can change 36 to 6 squared. Now, do they have the same bases? We created the bases to be the same. Now, what can we do? What can we do? We can drop off the bases and set 2x minus 10 equal to 2. Y'all see that? So we're creating the bases to be the same. That way, we can drop those bases off and solve. Now, in this case, what do I do to solve? What do I do to get x alone? I'm going to add 10, right? What's 2 plus 10? And then finally,
Divide by 2.
divide by 2. What's 12 divided by 2? So my solution to this exponential equation is x equals 6. Okay? Does that make sense? Okay, let's keep doing some of these. This one's got another little challenge to it. The left side has 7 to the 4x plus 11. The right side has 1 over 7. make these have the same base? I can't simplify either side, so I'm at step 2. Can I make these have the same base?
Reciprocal.
Very good. How can I make 1 over 7 be the base 7? It's all about the reciprocal. What allows me to flip 1 over 7 to make it 7? It's an exponent. What kind of one? A negative one. Negative exponents allow us to flip that base, and that's how we can change 1 over 7 to 7. When we flip it, it makes it a negative exponent. So 7 to the negative 1. Now on the left side, we already have 7, don't we? So I don't have to do anything to it. So I'm left with 7 to the 4x plus 11 equals 7 to the negative 1. Why do we do this? Because now my bases are the same. So we can drop those bases off, and we can take those remainders, 4x plus 11 equals negative 1, and we can solve it. Okay, again, I got to get x alone. What do I need to move first? How do I move that positive 11? You subtract it. What's What's negative 1 minus 11? Negative 12. And then finally, what do we do to break that 4 away from x? We divide. What's negative 12 divided by 4? So x equals negative 3. Okay? Questions about that one? One more, then we're going to step our difficulty level up just a little bit. Now, this might be a little harder for you, but again, think about it, guys. Our first thought is going to be to change the bigger value down to the smaller value, right? We're going to try to make 27 turn into a 3. If that doesn't work, we'll back up and change it. So let's think about it. Can I make 27 have a base of 3? All right, well, what's 3 times 3? 9. That's not it. Times 3, 27. So we can make 27 have a base of 3, 3 to the third power, 3 cubed. So we're going to change 27 to be 3 cubed. Now here's the thing. You can't forget about the exponent that was already there, okay? Put it off to the right, and we'll deal with that in a second. But I don't need to change that side. So here I'm left with 3 to the third times that other exponent was there, 2x plus 6, equals 3 to the 2x. We made our bases the same. What can we do with them? We can drop them off. Now, we distribute. What is 3 times 2x?
6x.
What is 3 times positive 6?
18.
So 6x plus 18 equals 2x. So when you have a situation like that where it already had an exponent up there, when we change that to 3 cubed, you're going to take that 3 and distribute it to the exponent that was already up there. Because it all belongs up there. So you combine it all. Now, I like to move the smaller variable. Which one's smaller, 6x or 2x? So I like to move the 2x. I'm going to subtract it. I know that that leaves that side empty. So I call it 0. So 4x plus 18 equals 0. Now what do I do to solve?
Subtract 18.
What is 0 minus 18? And then finally, divide by 4. What's negative 18 divided by 4?
Negative 4. Or x.
Negative 4.5. Yeah, negative 4.5. Yeah, that's a negative 18. Okay, so that's it. Okay, y'all understand this? Alright, so let's step up our difficulty level just a touch. Let me explain. Go to number 11 on the back. My first thought with this problem is, let's make the bigger one equal the smaller base. So I'm going to try to make 125 have the same base as 25. So what's 25 times 25?
I'm not.
What's 25 times 25? 25 squared. 625. So what did I do? I just went right past 125. So can I make 125 have the same base as 25? Not like that. So I got to think, all right, well, maybe I can't make 125 25, but maybe I can make them both something else. What could we make both 125 and 25 have the base in common? 5. Yep, because what's 5 times 5? So 5 squared is 25. But what's 25 times 5? So 5 cubed is 125. So we have to sometimes back both of the numbers down to different bases. So here I made 125 turn into 5 cubed, and I made 25 back down to 5 squared. They both had to go to a different number below it. Okay? When you can't make them the same as one base, you got to make both bases the same as another. If that makes any sense, the way I said it. So on the left side, now that we've got the bases the same, drop them off. What are we left with on that left side? 3y. What are we left with on the right side? This is a pretty easy problem now, isn't it? So we divide by 3, so y will equal 2/3. And that's done. Okay?
So homework is on the right side?
Yep. Alright, let's keep going. Number 13. Obviously, we're in these harder problems, but my mindset still is, can I make 8 a 4? So I go 4 times 4 is 16. I went right past 8. So I can't make 8 a 4. So can I make 8 and 4 both something else? 2. What's 2 times 2?
4.
So 2 squared will be the 4. But what's 2 times 2 times 2? 2 cubed will give me the 8. So I'm going to change this 4 to what? 2 squared. Don't forget about the 3x already there. I'm going to make this 8 a 2 cubed. And again, don't forget about the x minus 1 that's there. Now, did I make my bases the same? So drop them off. They're gone. What's left on the left side? What's left on the left side? 6x, right? 2 times 3x, 6x. Equals, what's left on the right side? 3x minus 3, right? 3 times x, 3x. 3 times negative 1, negative 3. So 3x minus 3. All right, so I want to move a variable. Which one do I like to move, the 6x or the 3x? I like to move the smaller one. How do I move positive 3x? Subtract it. What's 6x minus 3x? So we have 3x equals negative 3. Remember that negative has to follow it. Now what? Divide by 3. So what's negative 3 divided by 3? There's my answer. X equals negative 1. All right, another one. Number 15. Again, my first thought. Let's make 32 and 8. 8 times 8 is, I went right past 32. So I can't do that. So I try 4. What's 4 times 4? I just went straight past 8. So 8 didn't work. 4 didn't work. 2. Let's try 2. What's 2 times 2? 4 times 2. There's that one. 8's 2 cubed. 8 times 2? 16 times 2? So 2 to the 5th gives me 32. So we had to back this all the way down to 2. So 2 cubed gave me 8. And 2 to the 5th gave me 32. Yeah, that was a little. Yes.
So if they're both even, can you just do 2? Like, wouldn't that just
You
be
could.
easier?
Yeah, if they're both, not all evens can be, 2, like a 20. 20 is even, but can I go 2 times 2 times 2 get 20? No. So not all of them necessarily, just because it's even, has a base of 2 to some power to get that. So you might want to try other things first. Like 20, you wouldn't be able to change it. But we'll get to that when we do the logarithm part. All right, so we got our bases the same here. So drop those off. What's left on the left side? What is 3 times 2a minus 1? So we have 6a minus 3. Everybody see that distributive property? Now on the right side, what's 5 times 2a plus 1? So we have 10a plus 5 over there. Again, I always like to move the smaller one. Which one's smaller, 6a or 10a? So I'm going to move that 6a by subtracting it. So negative 3 will be left over there. What is 10a minus 6a? 4a. So 4a plus 5 is left on the right side. To solve for a, the first thing we need to get rid of is the 5. How? You subtract that 5. What's negative 3 minus 5? So negative 8 equals 4a. So last step, divide by 4. What's negative 8 divided by 4? So a equals negative 2. A equals negative 2. All right? Everybody understand that one? Okay, you got 2 more. They step up just a touch in difficulty maybe. Look at 17. Again, my first thought is, looking at the right side, I see some bases that are 4. So I think, can I make 64 a 4? Let's see. What's 4 times 4? 16 times 4. There it is. We can make 64 have a base of 4. 4 cubed. Exactly, we can. So I'm going to change 64 to be 4 cubed. Now I'm to the right side, and I think, hey, there's 2 4s. Same base. So let's get those together. How? What did we do earlier when we're multiplying and the bases are the same? How did we combine them? We added them. So if we look up there, what's understood to be the exponent with that first 4? So we combine those by adding. So that's 1 plus 4x. Am I allowed to combine those two? 1 plus 4x? No, because 1 has no variable, 4 has x. You're not allowed to add those. So you literally just leave it 1 plus 4x. So we combine that right side. Now the bases are the same. We only have 1 on both sides. So we do what with them? We drop them off. So 3 equals 1 plus 4x. I feel like you guys are doing really well with this. Am I right? Y'all feel good about it? So here, I want to get x alone. So what's the first thing I move? How? 3 minus 1. So 2 equals 4x. Lastly, we divide by 2 or 4? We divide by 4, right? We're trying to get x alone. Divide by 4. What's 2 divided by 4? 1/2 or 0.5. Again, I'll take either one. Okay, Aiden, kind of like that one you asked about earlier. Negative 11 over 2 or negative 5.5. Either one. 1/2, 0.5, either one. Whichever one you like. Okay? All right, last one. Got a bunch going on here. You got 1 over 7 as a base. You got 49 as a base. You got 7 as a base. Anybody see the common? 7, right? How do we make 1 over 7 a 7? 7 to the negative first. That's how you take a fraction and make it turn back up as the reciprocal 7. Okay? 7 to the negative first. Go over here to the right side. How do we make that 49 a 7? 7 squared. And then this 7's already good. Don't mess with it. It's already 7. Don't try to change something that doesn't need to be changed. Okay, on the left side, can I simplify anything? No, it's good. On the right side, though, since we have 2 7s, let's combine them to be 1 7. And how do we do that? By adding those exponents. Well, don't forget, that's 2 times x minus 5. So what will that be? So that's 2x minus 10 plus x minus 9. We're adding them, okay? We're adding them. So 2x minus 10 came from here, and we're adding it to x minus 9. We'll do that next, but what can we now do because the 7s are the same? Drop them off. So negative 1 equals, now let's do that. What is 2x? Remember, you can combine like terms. What's 2x plus 1x? So that 3x comes on down. And then we also have negative 10 minus 9. Remember, you're just combining them. You're not changing them into moving them. You're just combining them. So what is negative 10 minus 9? Negative 19. So now we're in great shape to solve. How? Add 19. What's negative 1 plus 19? Positive 18. Positive 18. And then, of course, to get the x alone, divide by 3. What's 18 divided by 3? 6. So there you have it. Okay, x equals 6. I want to show you one more thing before I put you out on your own. Go straight across the paper to the right. Y'all notice what the base needs to be from all of you the same? 4. Now here's the only trick. We didn't see one like this, is why I wanted to show you this. What do you get to get 16? 4 squared, right? But since this is a fraction, it won't be 4 squared, it'll be 4 to the negative 2. Okay? So again, the base is clearly 4. You know that 4 squared gets 16, so 4 to the negative 2 would have gotten you that 1 over 16. So for here, use 4 to the negative 2. Okay? So when you combine those, that'll be 4 to the 2x minus 2, because it's negative 2. Okay? You'll see that when you get to it. But I want you to see that first. So your homework due Monday is the right side of the page, all of these even problems. Again, we have just a touch of time left now. Probably not a lot to get done. You got 7 minutes, which is more than I had in any of my other classes. Does everybody feel good about what we've done? All right, then that's your homework. You can work on it now, but it's due on Monday.